Hi, welcome to 一乐一学 Charisma. In this video, we will go through the formulas that are required in Section 1, General Physics. Period means that time required to complete one oscillation. From this definition, we can develop up one formula. Average time period of an oscillation will be equal to total time divided by number of oscillation. The unit for the time is second, then average time period here, the unit will be second also. The next formula will be S equal to capital D divided by T. Capital D mean that distance with the unit meter. The T here is the time with the unit is second. The S here is the speed with the unit of meter per second. Average speed will be equal to total distance traveled divided by total time taken. With the unit for the total distance traveled is meter, the unit for the total time taken is second. So the average speed, right, the unit will be meter per second. The next one is the velocity. The velocity, right, the formula is V equal to S divided by T. In here, right, the S is the displacement with the unit meter, and then the T here, right, is time. The unit is second. V is the velocity with the unit meter per second. The next one is the acceleration. Formula of the acceleration is A equal to V minus U divided by time. V is final velocity or final speed with the unit meter per second. U, right, is initial velocity or sometimes also called as initial speed. Unit is meter per second. T is time taken. Unit is second. A is acceleration with unit meter per second square. For the motion graph, we have the two types of motion graph. The first one is distance time graph, and the other one is speed time graph. For the distance time graph, distance with unit meter, time with unit second, gradient will be equivalent to speed. For the speed time graph, if your speed is meter per second, time second, gradient will be equivalent to acceleration with unit meter per second square. Area will be equivalent to distance with unit meter. Weight W equal to mg. M is mass with unit kg. G is gravitational force, gravitational field strength. That is equivalent to 10 Newton per kg. W here is weight. The unit for the weight is Newton. Density will be rho equal to m over v. M is mass, unit for the mass is kg. V is volume. Unit is meter cube. Rho is density with unit kg per meter cube. From the Hooke's law, we have the one formula F equal to Kx. K is mean spring constant, or sometimes also called as force constant, with unit Newton per meter. X here is extension or compression with unit meter. Then the capital F here is applied force or root with unit Newton. For the Newton's second law, we have the one formula here, F equal to ma. M is mean mass with unit kg. A is acceleration with unit meter per second square. F here, you must take care about the F here, is resultant force with unit Newton. From the extension root graph, extension root graph gradient will be equivalent to 1 over spring constant. For the root extension graph, root extension gradient will be equivalent to spring constant with the unit Newton per meter. Moment will be equal to F times D. F is mean the force with the unit Newton. D is perpendicular distance from period, or sometimes we also can write as perpendicular distance from turning point. Unit is meter. Moment is moment, but sometimes also can call as turning effect with the unit Newton meter. Principal moment is mean sum of anti-clockwise moment will be equal to sum of clockwise moment. F1 D1 equal to F2 D2. A system in equilibrium, they have the two conditions for the system in equilibrium situation. The first one is no resultant force. The second condition here is no resultant turning effect. Okay, let's see the next one is for the momentum impulse. So for the momentum, P equal to mv. M is mass, kg. V is velocity, meter per second. The next one is P, is mean momentum, kg, meter per second. Impulse is equal to change in momentum. That is mean by final momentum minus initial momentum. with the formula mv minus mu. M is mass with unit kg. V is final velocity with unit meter per second. U is initial velocity with unit meter per second. Impulse also have the other one formula that is equal to Ft. F equal to force with the unit Newton. T is time with the unit second. Impulse have two units. One of the unit is kg meter per second and the other ones will be Newton per second. From this conservation of momentum, it means sum of momentum before collision will be equal to sum of momentum after collision. For the elastic collision, we will use this formula m1u1 plus m2u2 equal to m1v1 plus m2v2. For the case in elastic collision, m1u1 plus m2u2 equal to m1 plus m2 bracket times v. For the explosion, 0 will be equal to m1 v1 plus m2 v2. From the formula, m1 is mean mass of car 1 with the unit kg. m2 is mass of car 2 with the unit kg. u1 is initial velocity of car 1 meter per second. u2 is initial velocity of car 2 meter per second. Then the v1 is final velocity of car 1 meter per second. v2 is final velocity of car 2 meter per second. The last one is v. v is common velocity of car 1 and 2 together with the unit meter per second. The next one is kinetic energy. Ke equal to half mv squared. M is mass, kg. V is velocity, meter per second. Ke is kinetic energy with unit J, joules. Gravitational potential energy, GPE, equal to mg delta H. M is mass, unit is kg. G is gravitational acceleration with 10 meter per second square. Delta H is change in height with unit meter. GPE stand for gravitational potential energy, joules. We have the two formula to find out efficiency. Efficiency equal to useful energy output divided by total energy input times 100%. Unit for the energy output is joule. Unit for the energy input is joule. Efficiency is %. The next formula for the efficiency is useful power output divided by total power input times 100%. Unit for the power output is watts, W. Power input, watt. Efficiency, %. Work done. Work done will be equivalent to energy transfer. W equal to F times D. F is force with the unit Newton. D is distance moved. And then this one must have same direction with force. Unit is meter. W is work done with unit joules. Power P equal to delta E over T or W over T. Delta E is energy transfer. Unit is joule. W is work done. Unit is joule. T is time taken. Unit is second. P is power with the unit watts. P equal to F divided by A. F is force, Newton. A is area, unit is meter square. P is pressure, unit is Newton per meter square. But normally we will be write as Pascal. PL equal to H rho G. H is depth of liquid. Unit is meter. Rho is density. Unit is kg per meter cube. G is gravitational field strength. Newton per kg. PL is liquid pressure with the unit Pascal. Okay, so that is finish our session 1, all the formulas. Section 2, thermal physics. For the Boyle's law, the formula is P1 V1 equal to P2 V2. P1 is pressure in situation 1. P2 is pressure in situation 2. For the unit P1 and P2, just need to make sure they have the same unit. Whatever is Pascal or Newton per cm square, just need to make sure if both have the same unit. V1 is volume in situation 1. V2 is volume in situation 2. Same as P1 and P2, just need to make sure V1 and V2 have the same unit. You can use both is meter cube or both cm cube is already. The next one is Charles' law. V1 over T1 equal to V2 over T2. V1 volume in situation 1. V2 is volume in situation 2. Make sure it have the same unit. Both is meter cube or cm cube is suitable. T1 equal to temperature in situation 1. T2 is temperature in situation 2. For the T1 and T2, you must use the unit Kelvin. Okay. Pressure law is P1 over T1 equal to P2 over T2. P1 is pressure in situation 1. P2 is pressure in situation 2. Make sure it have the same unit. Whatever is Pascal or Newton per cm squared. T1 is temperature in situation 1. T2 is temperature in situation 2. It is need to measure the unit for the T2 and T1 is Kelvin. Okay. Thermal capacity, the formula is capital C equal to mc. M is mass, unit is kg. C is specific heat capacity. Unit is J per kg degrees Celsius. Capital C is heat capacity. Unit is Joule per degrees Celsius. Specific heat capacity, the formula is C equal to Q over M delta T. But normally we will be write this formula as this form. Q equal to mc delta T. Q is thermal energy. Unit is joules, J. M is mass. Unit is kg. Delta T is change in temperature. Unit is degrees Celsius. C is specific heat capacity. Specific heat capacity, unit is J per kg. They have the two formula related to specific latent heat. One of them is Q equal to mLF. Another one is Q equal to mLV. M is mass, kg. LF is specific latent heat of fusion. Unit is Joule per kg. LV is specific latent heat of vaporization. Unit is Joule per kg. Q is thermal energy. The unit is J, joules. Alright, we finished all the formula in section 2. we will go through the required formula in section 3, properties of wave including light and sound. The first formula that we want to look is V equal to F lambda. F is frequency, unit is Hertz. This symbol is called as lambda. Lambda is wavelength. The unit is meter. V is speed of wave with unit meter per second. The next one is frequency equal to 1 over t. T is period. The unit is second. F is frequency. Unit is Hertz. For the law of reflection, the formula is I equal to R. I is mean angle of incidence. Unit is degree. R is angle of reflection. Unit is degree. For the refractive index, they have three formulas. One of the formula is N equal to C over V. C is speed of light in vacuum. The unit is 3 times 10 power of 8 meter per second. V is speed of light in medium. Unit is meter per second. N is refractive index. No unit. The next formula for refractive index is sin I over sin R. I is angle of incidence. Unit is degree. R is angle of refraction. Unit is degree. N is refractive index. No unit. Formula for refractive index in terms of practical angle is N equal to 1 over sin C. C is critical angle in degree unit. N is refractive index. No unit. For the speed of sound, when the sound is solid, speed is approximate 5,000 meter per second. In liquid, speed of sound is approximate 1,500 meter per second. When it's in gas, it's approximate 330 meter per second. Formula for the echo is V equal to 2D over T. D is distance between source and the reflection surface. Unit is meter. T is time for echo. Unit is second. V is speed of sound wave. Unit is meter per second. Alright, we finished the required formula in section 3. Section 4, electricity and magnetism, and section 5, atomic physics. Formula for the electric charge is Q equal to IT. Then this formula also can rearrange become I equal to Q over T. Q is charge. Unit is C, coulomb. T is time. Unit is second. I is current. Unit is A, ampere. V equal to W over Q. W is work done. Unit is joule. Q is charge. Unit is coulomb. V is potential difference, and also can call as voltage. Unit is V, work. Resistance R equal to V over I. But normally we will be write this formula as V equal to IR. V is voltage. Unit is volt. I is current. Unit is ampere. R is resistance. Unit is ohm. For the current voltage graph, y-axis is current, ampere, x-axis is voltage, volt. Gradient of current voltage graph will be equivalent to 1 over resistance. For the voltage current graph, y-axis is voltage, x-axis is current, ampere. Gradient of voltage current graph will be equivalent to resistance. For the resistivity, resistance directly proportional to length of conductor. Resistance will be inversely proportional to cross-sectional area of conductor. When these two relationships combine together, R will be directly proportional to L over A. When changed to equation, R equal to constant L over A. Then this constant number will be rho L over A. Then when we rearrange this formula, rho will become equal to RA over L. R is resistance. Unit is ohm. A is cross-sectional area. Unit is meter square. L is length of wire. Unit is meter. Rho is resistivity. Unit is ohm meter. I have 4 formula for power. P equal to E over T. P equal to VI. P equal to I square R. And the last one will be P equal to V square over R. E is electrical energy. unit is joule. T is time taken, unit is second. V is voltage, unit is volt. I is current, unit is ampere. R is resistance, unit is ohm. They have the three formula for electrical energy. E equal to VIT. E equal to I square RT. E equal to V square over RT. V is voltage, unit is volt. I is current, unit is ampere. T is time taken, unit is second. R is resistance, unit is ohm. For series circuit, E will be equal to E1 plus E2 plus E3. E is electro multiforce, unit is volt. V. IT total current equal to I1 equal to I2 equal to I3. I is current, unit is ampere. VT total voltage equal to V1 plus V2 plus V3. V is voltage, unit is volt. RT total resistance equal to R1 plus R2 plus R3. R equal to resistance, ohm. IT total current equal to I1 plus I2 plus I3. I is current, ampere. VT equal to V1 equal to V2 equal to V3. V is voltage, unit is volt. 1 over RT, 1 over total resistance equal to 1 over R1 plus 1 over R2 plus 1 over R3. R is resistance, unit is ohm. Formula for potential divider is V2 equal to R2 over R1 plus R2 times V. V1 equal to R1 over R1 plus R2 times V. For the transformer, they have the three components for transformer. Soft iron core, coil connected to AC power supply, called as primary coil. And the last one component is secondary coil that is connected to electrical equipment. They have the two formula related to transformer. Vp over Vx equal to Mp over Ns. Vp is primary coil voltage. Vs is secondary coil voltage. Unit is volt. MP is number of turns of primary coil. NS is number of turns of secondary coil. For a 100% efficient transformer, formula is VPIP equal to VSIS. IP, primary coil current. Unit is ampere. IS, secondary coil current. Unit is ampere. For the section 5, nuclide notation, X, A, Z. X is element symbol. Z is proton number or electron number when the atom is neutral. A is nuclide. There is number of proton plus number of neutron. Alright, we finished the formula in section 4 and section 5.